Hi students, today I am going to discuss about the Fraunhofer diffraction at single slit. This is an essay question. The weightage of this question is around 10 marks in BTech, of course in BSc also, which is very important. If you understand this question, you can answer the further questions like Fraunhofer diffraction due to two slits, Fraunhofer diffraction due to n slits, and etc. So if you learn carefully this question, you can answer any question in diffraction. Very easy. So the Fraunhofer diffraction due to single slit. If there is a slit, assume one slit, and a monochromatic light is passing through that slit. Then what happens? A wavefront forms in front of the slit. A wavefront. That wavefront consists of number of secondary wavelets. Here, the diffraction pattern forms due to because of the superposition of the secondary wavelets, which belongs to the same wavefront. Now, I have to find the path difference between two rays. Generally, first step, I have to find the path difference between two beams. Then find the corresponding phase difference between two waves or two rays or two wavelets. Then find the amplitude of the wavefront. Then find out the amplitude of the wavefront. Then check the case studies like the condition for maximum intensity, that means the position of the maximum intensity and the magnitude of the maximum intensity I have to find. Then the condition for minimum means the position of the minimum intensity and the magnitude of the minimum intensity. Then finally we have to find the positions of the secondary maxima and the magnitudes of the secondary maximum. That means the first peak is called principal maxima. Either sides of the principal maxima there is a minimum. To find out the intensity of principal maxima, minima and secondary maxima. The either sides of the principal maxima there is an decreasing intensities of peaks. So how much the intensity is decreasing, like that I have to find out. Let us start the session. Fraunhofer diffraction at single slit. Consider a single slit of AB. This is a very smallest slit. The width of the slit is small e. Then what happens when a slit is taken? This is a parallel beam of monochromatic light, WW dash. This light enters into the slit. Then here a wavefront forms like this. Here a wavefront forms. Thus that wavefront consists of number of secondary wavelets. Here the secondary wavelets which are parallel to the incident beam, they form image at P0. Image in this sense that should be a bright or dark fringe on screen. This is screen. The secondary wavelets which are making an angle theta with the incident beam, That means the incident beam line is this. The secondary wavelets which are having an angle theta, they form image at P. So this is the pattern. This is the pattern of diffraction of light that we have to prove. Here this peak is called principal maxima or primary maxima. This is minima. These are minima. This is called secondary maxima. This also secondary maxima. Here this is principal maxima. This is first subsidiary maxima. This is second subsidiary maxima. Now our aim is to calculate the position of the principal maxima. That means where the position is, and the intensity of the principal maxima. Then find the position of the minima, like series of minima. Then find the position of the secondary maxima. Secondary maxima means this is first subsidiary maxima, this is second subsidiary maxima, and the magnitude of the intensity. That means the difference of these two intensities we have to find. How much times it decreases its intensity from this principal maxima, and comparing with this. Finally, what happens? Here the central maxima is very bright. This is somewhat dim. This is dim. The subsidiary maximas are in dim. That means the lighting in decreasing order. After certain distance, the intensity should be 0. That we have to prove in this question. Here we indicate E, small e is a slit width, lambda the wavelength of light we know, and the path difference between two rays. The path difference is BC. We have to start our expression part from here. So find the path difference is of two rays. So path difference BC. To find the path difference BC we have to find. For that we have to consider the triangle ABC. Here BC is opposite side, then this is hypotenuse. AB indicates hypotenuse, so we have to take sine term because opposite by hypotenuse. Take sine theta is equal to opposite means BC by hypotenuse means AB. Hypotenuse means AB. Then AB means E, so sine theta is equal to BC by E. Therefore BC is equal to E sine theta. This is equation number 1, which is the path difference between two rays. Now find the corresponding phase difference. So the phase difference is the corresponding phase difference is equal to wave number into path difference. I mean the product of wave number and path difference. So phase difference phase difference is equal to wave number is nothing but the 2 pi by lambda into path difference means e sine theta. E sine theta. This is equation number 2. Now, how many secondary wavelets are crossing this slit AB? How many secondary wavelets are crossing this slit AB? That means n number of secondary wavelets are crossing this slit. So I want only 2 secondary wavelets. I want the phase difference between 2 secondary wavelets. So I have to divide this AB slit into n equal parts, not n parts, n equal parts first of all. That means each part represents one secondary wavelet. So n number of secondary wavelets are crossing the slit of AB. So divide the slit into n equal parts. Then the phase difference between any 2 secondary wavelets is 1 by n into total phase difference is equal to 1 by n into 2 pi by lambda into e sin theta, which is d. Let. This is equation number 3. That here we divided the slit into n equal parts. Then each part representing a secondary wavelet. So the phase difference between 2 secondary wavelets are like this. We know the resultant amplitude of wavefront by vector addition method, that is R is equal to a sin n d by 2 divided by sin t by 2. This is equation number 4. Here a is equal to amplitude of wavelet, n means order, d means phase difference, it means phase difference. Now put equation 3 in equation 4. Then this equation 4 becomes R is equal to a sin n into d means 1 by n 2 pi by lambda e sin theta into e sin theta by 2 whole divided by sin d means again 1 by n 2 pi by lambda e sin theta divided by 2. Now n gets cancelled. Then r is equal to a sine 2 pi by lambda into e sine theta whole divided by 2. This 2 and 2 again gets cancelled and divided by sine this 2 also gets cancelled. 1 by n 1 by n pi e sine theta. Then the resultant amplitude of wavefront r is equal to a sine pi e sine theta by lambda divided by sine of pi e sine theta by n lambda. This is n lambda, pi e sine theta by n lambda. Here r is equal to, by simplifying this equation, we get a sine alpha divided by alpha by n, where alpha is equal to pi e sine theta by lambda. At this place we can use alpha. Then r is equal to a n sine alpha by alpha. Here a is called amplitude of the individual secondary wavelets, n means order or number. We know, you better know, alpha is equal to pi e sine theta by lambda. Here a, an individual secondary wavelet, n means n number, then a into n gives capital A sine alpha by alpha. Here don't confuse, this is a, small a represents a secondary wavelet's amplitude. If there are n number of secondary wavelets are there, the product of these two gives the total amplitude of the wavefront. Suppose this is the wavefront, if this is slit, this is wavefront. In this wavefront there are n number of secondary wavelets. These are secondary wavelets. These are, small a represents one of the secondary wavelets. Here n number of secondary wavelets are there. This vibration into n gives the total wavefront's amplitude. This is equation number 5. But the intensity, we know intensity I is equal to r square, that is equal to a sine alpha by alpha whole square. This is the general equation of the intensity. Now we have to calculate the intensity at principal maxima, the intensity at minima, the intensity of secondary maxima. That means first subsidiary maxima, second subsidiary maxima, and etc. First of all, we have to find the positions of the principal maxima and minima by using this equation 5. Then for secondary maxima situation, we have to use this equation. Now condition for principal maxima, I have to take that equation r is equal to a sin alpha by alpha, where alpha is equal to pi e sin theta by lambda. Here the condition is the resultant maximum, the resultant is maximum, the resultant is maximum at alpha is equal to 0. That means the denominator is equal to 0. Mathematically, if we examine this, if this denominator is equal to 0, r becomes infinity. So here alpha is equal to 0, but sine alpha is not equals to 0. In this equation, a not equals to 0, but sine alpha also not equals to 0. Then only this equation becomes infinity. So for this we have to use L'Hospital's rule. That means limit alpha tends to 0, sine alpha by alpha is equal to 1. That by LH rule, L'Hospital's rule. Then sine alpha by alpha is equal to 1, but the intensity, that means L'Hospital rule. Now equate pi e sine theta by lambda, that is alpha is equal to 0. Already we took alpha is equal to 0. Now substitute this 0 with this equation is equal to 0, is equal to 0. Then sine theta is equal to 0, sine theta is equal to 0, then theta is equal to 0 degrees. That means this is condition for principal maxima or primary maxima. In this pattern only single principal maxima exists here. So this is 0 degrees. At 0 angle only it gives a principal maxima. Here intensity I is equal to a sine alpha by alpha whole square, that is equal to a, this is a, sine alpha by alpha becomes 1 according to the LH rule. Therefore this becomes 1, then this will be a square. Here this is the maximum intensity. So Imax is equal to a square. This peak contains maximum intensity. Suppose this is the pattern. This is the pattern. This is principal maxima. This is at origin O, 0. This will be having maximum intensity, that is a square. This should be the maximum of this peak. This is secondary maxima. This secondary maximum intensity should be a square by something like that. So this is the intensity of the principal maxima. Now condition for minima. Now we have to find the condition for minima, the position of the minima and the intensity of the minima. It is condition for minima. Condition for minima. Again we have to take r is equal to a sine alpha by alpha, where alpha is equal to pi e sine theta by lambda. But here r becomes minimum. So if r becomes minimum means the numerator of this expression should be 0 or minimum value. That means here sine alpha is equal to 0, but alpha not equals to 0. That means denominator not equals to 0. That means the numerator is equal to 0, but a cannot be equals to 0. So here sin alpha is equal to 0. Then alpha is equal to n pi. This is m pi. This is minimum pi, where m is equal to 1, 2, 3, 4 up to n. Here in previous condition there is only one principal maxima, that's why I have taken theta is equal to 0 degrees, but here the minimas are there, number of minimas are there, so we have to derive the general equation, that is m pi, but m not equals to 0. If m equals to 0, this minimum comes, or the minimum clashes with this principal maxima, so that will be wrong. So we have to take the options from 1. Then this m pi, this alpha value equate with this value, that is pi e sin theta by lambda is equal to m pi. Pi and pi gets cancelled. E sin theta is equal to m lambda. E sin theta is equal to m lambda, where m is equal to 1, 2, 3, 4 up to n. But the intensity should be 0. If r equals to 0, then r square also 0. That means I is equal to r square is equal to 0 square. Then the intensity of minima is equals to 0. This is a dark fringe. Here whenever the intensity is 0, this represents a dark fringe. Now condition for secondary maxima. For that we have to take the intensity equation a sin alpha by alpha square whole square. Differentiating this equation and equates with 0, because already I told you this is the pattern. This is the pattern. This is maximum intensity. This is maximum intensity, that is a square. Then these are secondary wavelets, first subsidiary maxima, second subsidiary maxima. This also first subsidiary, this is second subsidiary. Now we have to find these secondary maximas intensity values. How much intensity? This also like this, but the variation is intensity. This is bright spot, this is somewhat dim, looks somewhat dim, this is very dim. It becomes, after certain distances, it becomes the 0 intensity. That's why I equated this equation with 0. So taking differentiation, di by d alpha is equal to a sin alpha by alpha whole square, that is di by d alpha is equal to 0. That means d by d alpha of a sin alpha by alpha whole square is equal to 0. By differentiating this equation, that is 2 into a sin alpha by alpha into, this is d by dx of u by v. That means take out this a, this becomes a square. U by v means this is alpha square, alpha into d by d alpha of sin alpha minus sin alpha into d by d alpha of alpha equals to 0. By solving this equation, 2 into a square sin alpha by alpha into alpha into d by d alpha of alpha means cos alpha minus sin alpha. This becomes 1 divided by alpha square. This is equal to 0. In previous conditions, we have taken this equation, that is denominator is equal to 0, which gives maximum intensity, numerator is equal to 0 gives minimum intensity. Now for secondary maxima we have to consider this equation, that is alpha cos alpha, take alpha cos alpha minus sin alpha is equal to 0. Then alpha cos alpha is equal to sin alpha. Alpha is equal to sin alpha by cos alpha. Alpha is equal to tan alpha. This alpha is the tangent. That means the tangent will maximum at here the LHS alpha will be maximum at every 90 degrees or every pi by 2. That means alpha is equal to plus or minus 3 pi by 2 plus or minus 5 pi by 2 plus or minus 7 pi by 2. This indicates the positions of the secondary maxima. Just now I told you the positions of the secondary maximas, plus or minus 3 pi by 2, 5 pi by 2 and 7 pi by 2. So the subsidiary maxima, the intensity of first subsidiary maxima I1 is equal to a square sin 3 pi by 2 by 3 pi by 2 whole square. This is by solving this equation we get a square by 22. That means when compared to principal maxima, this principal maxima, this peak, the intensity of this peak is a square by 22. That means the intensity decreases 22 times. Similarly, I2 a square sin 5 pi by 2 by 5 pi by 2 whole square. This is a square by 61 point something. So the intensities ratio is 1 is to 1 by 22 is to 1 by 61 is to 1 by 121 and etc. But the intensity of principal maxima I max is equal to a square. I min is equal to 0. Minima is equal to 0. Then the diagram is like this. The final diagram we have to plot in your examination. This is 0. This is pi. This is minus pi. This is 2 pi. This is minus 2 pi. This is 3 pi by 2, the position of the secondary maximum. This is position of the secondary maximum minus 3 pi by 2, the position of the second subsidiary maximum 5 pi by 2, the position of this second subsidiary maxima is minus 5 pi by 2 and so on. Here the intensity is maximum. This is a square. This is a square by 22. This is a square by 61. Like the intensity should be in decreasing order. After certain distance, the intensity becomes 0. So this is the solution proof of Fraunhofer diffraction at single slit. Then we will continue in next video. I will explain you the Fraunhofer diffraction at two slits. Thank you.